working on lesson 4, which is talking about probabilities. So we're going to go to part 2, where it says a 4-sided die has 4 possible outcomes for each roll: 1, 2, 3, or 4. Calculate the mean of this discrete random variable. So that was at the end of the chapter, if I remember right.
Yeah. Okay, so for each value, well, for each number, there's 1/4 of a chance.
Mm-hmm.
So then, don't you just multiply the number by the, like, chance?
Oh yeah, for the value, huh?
Mm-hmm.
So it would be like,
1 times 0.25, and so on.
yeah. Yeah. So, do you want to make a table of it, or do you just want to like type them in there?
So we could just make a table of it. Well, I mean, type it in there.
Okay. So, for 1,
So that would be 0.25 for 1. So I don't get, like, do you just add all of them together, or do you add them all together and then divide?
let's see. I think for this part, I think we were just finding the mean of each one. So I think it'd be 1 would be 0.25, and then 2 would be 0.5, 3 would be 0.75, and 4 would be 1, right?
Yeah.
I think that's what we have to do for this one. Then maybe add them up to see what the sum.
Okay, I mean, I looked on the answer key and it said, like, sum is like 2.5.
Yeah.
So, but I just added it up and it was like,
You got 1.75. Yeah, that should work as 0.25 plus 0.5 is 0.75. Plus the 0.75 is 1.5. Plus the 1 would be 2.5.
okay.
Okay. You ready to go on?
The
I think so. That's all the answer key has.
Okay, so the next one is calculate the standard deviation of this discrete random variable. And so it's just like a continuation of the chart.
So
I know you multiply it by 0.25.
Yeah.
And then don't you subtract 2.5 from the value?
yeah,
Uh-huh.
and then so
Then you square it.
let me grab your calculator.
So n would be negative 0.5625.
For the first one,
Yeah.
I think it's a positive because it's squared, so it takes the negative out.
Oh yeah. I forgot to do that on my calculator. Okay, so for 2 and 3, did you get the same number?
Not for 2. Let me make sure I did it right. Actually, yeah, it would be the same number.
Okay. And then I got the same number for 4 and 1.
Yeah, that makes sense. So then we add those together.
Mm-hmm. Okay, I got 1.25.
Pretty cool.
Yeah. So we take the square root of that.
Wait, why do we take the square root? Like, I know we're supposed to, but is that just how you find standard deviation?
Yeah, I think so.
Okay.
That makes it 1.118. So that's it, right?
Yep. And then we just need to do the quiz.
You ready?
Yep.
All right, here we go. Yes. All right. Says no. Give all your probability answers as decimals. For example, 0.1234. Do not give probability answers as percents. Human blood can be classified into one of our basic types: O, A, B, and AB. The proportion of people in the population of the United States with each of these blood types is summarized in the following table. Use this data to answer the following questions. The blood types and proportions given in the table above define a probability distribution. I think that's right, isn't it?
I think so too, because none of it's more than 1. Because if it's a probability, it's either 0 or 1
And those
for the distribution.
all add up to 1 too, so I think that's right. I think that's true.
Yeah. So for the next answer, well, do we already read it?
No, we haven't.
Okay, so what is the probability that a randomly selected person in the United States has type O blood? At 0.1125. Because you multiply the 0.45 by the 0.25. And yeah, I got 0.1125.
That's what I got too.
Okay, but it says round to 2 decimal places.
Right.
So it'd just be 0.11.
Yeah.
Okay. What is the probability that a randomly selected person will not have type O blood?
So
Then do you multiply it by
it should just be 0.89, shouldn't it?
Yeah, I think so.
I mean, because it has to equal up to 1, doesn't it?
Yeah.
I thinking wrongly.
I don't know.
Where's your iPad?
Okay, next one.
Yeah.
Are we ready?
You can go ahead.
Okay, Carolyn Willis and her colleagues conducted a study in which dogs were trained to detect bladder cancer. The dogs were trained to lie down next to a specimen derived from a bladder cancer patient. Tangle, one of the dogs, demonstrates the identification of a specimen. 7 bowls containing urine were lined up in a random order. 6 of the samples were from patients who did not have bladder cancer. 1 of the samples came from a person identified as a bladder cancer patient. Answer the following question. If the dog guess at random, what is the probability that they will correctly identify the dish containing the specimen from the bladder cancer patient?
So isn't it just
Wouldn't it be like 0.143?
Yeah, I think that's it. That makes me wonder about this other one though that's up top. If the greater proportion of people have 0, shouldn't the randomly selected person have a B? Shouldn't the probability be higher than 0.11?
I don't know, like for that, I think it's kind of easier because you actually have like values. But for this, I don't know, because I'm just kind of confused.
Because this is saying if the proportion of the blood type O, it's almost half of the people. It's like,
Yeah, you're okay. I see what you're saying.
Yeah.
what's the difference between proportion and probability again? I don't know, I feel like number 4, are we thinking too much? Is it just 0.45?
Number 4. Is that what you're saying?
Yeah.
Yeah, I could see that.
Okay, let's do that.
So then the probability the person does not have it is 0.55. All right.
Good catch.
Yeah, already got it. Okay. Then number 6. You already read it.
I already did 6. It's 0.41,
Oh.
0.143. Let me read it so we can see.
In a combined total of 54 trials, the dogs correctly identified the specimen from the cancer patient 22 times. It is very unlikely that the dog would do this well by random chance alone. Which of the following statements is most appropriate? This provides strong evidence that dogs can detect bladder cancer. There is little evidence that dogs can detect bladder cancer. So out of 54 trials, they picked their sample 22 times.
That's less than 50%.
Yeah. So there's little evidence.
I would say.
I would say so because it's not really giving like a reason why they did pick it. You know.
Yeah.
M&Ms are small chocolate candies. The M&M website previously indicated that in the United States, distribution of colors in a bag of plain M&Ms is given the following table. If you reach into a bag of plain M&Ms, what is the probability of drawing a red colored candy?
Okay, why is green crossed out?
I was just wondering the same thing. I don't know.
Hmm.
And should we count that as one of the colors?
I'm thinking, because I feel like if she didn't want us to, the actual, like, green would be crossed out.
It like wouldn't even be there.
Yeah.
I don't know. I'm still guys. I'm confused if proportions are different than probability because I think you get proportions, or I think you draw. I still think it's 0.13.
Yeah. Me too.
I guess I'm just confused because she says round to the nearest two decimal places. So I feel like I should be multiplying something, but I don't know what I should be multiplying.
Well, should we just do it like we did in the other one? Where you multiply it by the 1 divided by 6?
So we can try that.
If we do that, then I got 0.02.
Hey,
That's what I got.
That's too small.
But yeah, I mean, I do think it's too small too. But at the same time, I feel like
It's way too small.
how could the answer just be there? You know what I mean?
But 0.02. That's
I know, I understand that's really small, so I don't get how we would do that either. Well, because then if you look at the next question, it says, what is the probability that a randomly selected candy is green? And since we don't know that, I added them all up and then subtracted it by 1 because you get 0.84 and you get 0.16. So then that answer would be 0.16 and then everything added up. So then the number 10 would be 0.84. Do you know what I'm saying?
Mhm.
I think we're overthinking it.
That's right. That ain't go right.
Okay. So the ACT scores of students admitted to a medium-sized public university in the western United States were taken from kpex.com. The following summary statistics were calculated. Use the information from the public university to answer the following questions. Half of the observations are less than or equal to what number?
It's from last time.
Oh.
So half would be equal to 24. That's the median, right?
Yeah.
We all agree it's 24? According to based on the information on the table above, the top 25% of the students scored above what number? 27, right?
Yeah.
Okay, which of the following statements is not one of the 3 rules of probability? The probability that an outcome will not occur, probability that it will. The sum of the probabilities in any probability is 1. If the probability is high, then the probability is positive, and the probability is a number between 0 and 1. I'm thinking the third one down. Is
The
it?
probability is positive. If high, it is positive.
Yeah.
Yeah, me too.
Yeah.
All right, so we ready to submit?
Yep.
-3. Oh, what? I don't believe that.
It's the dog one.
Yeah, that's weird. Oh, well.
Okay.
We will see you tomorrow.
Yeah, tomorrow at 7?
Yeah, is that okay?
Yeah.
All right, sweet.
Cool.
Thank
Okay,
you.
have a good night, guys.
Yeah.
Bye.